The next video in our mole unit is on percent composition. Just one learning target for this video. We want to be able to calculate the percent composition of a compound from its formula. So percent composition follows a simple equation. If I want to find the percentage of a component in a mixture or a compound, I just take the mass of A, where A is the substance or the element that I'm looking for the percentage for. I divide by the total mass and I multiply by 100 to turn it into a percentage. So let's just take a look at how this might work out. The first thing, or the first way we might find a percent composition is from experimental data. So for example, we're told a certain compound contains 28.0 grams of nitrogen and 16.0 grams of oxygen. It says to calculate the percent composition of each element in the compound. So if I want to find the percent composition of nitrogen, I'm simply going to take the mass of nitrogen divided by the total mass of the compound and multiply by 100. So in this case, that would be 28 grams of nitrogen divided by the sum of 28 and 16, because that would be the total, and then I multiply by 100. This should give you 63.6% nitrogen. I would then do the same thing for the oxygen. I would take the mass of oxygen divided by the total mass times 100. So in this case, 16 grams of oxygen divided by the total mass of the sum of 28 and 16 multiplied by 100, and that should give me 36.4. Now, once you calculate the percent composition of each element in a compound, you should fairly easily be able to check the answer by adding up those percentages. Notice they add to 100. They should add to 100, maybe not exactly 100. We'll see an example later, I believe, where it's not exactly. And the reason why it might not be exactly is because of your sig figs. In this case, both of these answers go to the same number of decimal places. So we probably should get exactly 100, and your calculator will give you exactly 100. If you have a circumstance where you don't have the same number of decimal places in your answer, then there's a good chance that it won't be exactly 100, but it should be extremely close to that. Here's another example. We're told when 221 grams of gold oxide are decomposed, 24 grams of oxygen are obtained. Calculate the percent composition of each element in the gold oxide. So we have two elements. We have gold, we have oxygen. Notice in this case, the 221 grams, that is the entire mass of the compound. We're told we have 221 grams of a gold oxide, so that is the mass of the compound. We're told that we get 24 grams of oxygen from that. So to find our percent composition of oxygen, we would just take 24 grams of oxygen divided by the total, which is 221, multiply it by 100, and that should give us 10.9%. Now, as far as the gold's concerned, to find the mass of gold, it would just be the difference between the 221 and the 24. So if you do that, 221 minus 24, what will that give you? 197 grams. If you plug that in and do the division, you should get 89.1% gold. And again, check your answer. They add to 100. You probably did it correctly. So there are a couple of examples of finding percent composition from experimental data. The more common way to have to calculate a percent composition is from the formula for the compound. So for example, we're asked to calculate the percent composition of each element in barium sulfate, where we're given the formula there, BaSO4. If I'm going to find the percent composition of the barium, we'll just start there because that's the first element that's listed. I'm going to take the mass that's barium divided by the total mass times 100. Now you might be wondering, where are we going to get these masses? We have no masses to work with here in the problem. There's no mention of how much of the stuff we have. The simplest thing to do is to simply go with 1 mole of the compound. The reason why that works, I know if I calculate the mass of a mole of this barium sulfate, that would just be the molar mass. I would know the mass of the compound, and then I could also simply give how many grams of barium would be in that mole. So if I look up the molar mass of barium, I can see it's 137.33 grams of barium. The 233.4, that's simply the molar mass of the compound. So if you calculate the molar mass of BaSO4, that's what you'll get. to 33.4. So whenever we're just given the formula, simply use the molar masses. You plug that in, your calculator should get 58.839% barium. We're going to do the same thing for each of the elements in the compound. Again, we'll just use the molar masses. Molar mass of sulfur is 32.07 divided by the molar mass of the whole compound. Multiply by 100, you'll get 13.74% there. Notice only 4 sig figs for the molar mass of sulfur. And then we'll do the same thing for the oxygen. Notice here, as far as the mass of the oxygen is concerned, 4 times 16, because there's 4 moles of oxygen in every mole of the compound. I can see that in the formula. And then we do the calculation, we get 27.42%. Plug that all in your calculator, it's going to tell you 99.999%. Here's an example we mentioned just earlier where you might not get exactly 100. The reason it's not exactly 100, notice as far as our decimal places are concerned, we go to the thousandths place in the percent composition for barium, but only to the hundredths place in the other two. So that's why it's not exactly 100. But if it's this close, that tells you you most likely did it correctly. Calculate the percent composition of nitrogen in strontium nitrate. And you can see we're given the formula there. Notice this question only asks us to find the percent composition of the nitrogen. So that's all we'll do. We'll find the mass of the nitrogen divided by the total mass of the compound. We'll have our percent composition. Notice here we have 2 moles of nitrogen. Look at the formula. There would be 2 moles of nitrogen in every mole of the compound. So 2 times 14.01. The molar mass of the whole thing is 179.64 grams. So that's where we get our total mass. Do the calculation, 15.60% nitrogen. So those are just a few examples there of how we calculate a percent composition of a compound. Simply, all we do is we take the mass of the element, whether it be from experimental data or using molar masses, and then we divide by the total mass of the compound and multiply by 100. That's percent composition.